Hello everyone. Today we're going to be looking at exponential functions and we'll look at how we can differentiate and integrate exponential functions. We're going to be first of all developing the properties of these natural exponential functions, differentiate these natural exponential functions, and also learn how to integrate the natural exponential functions. So the first thing is, what is a natural exponential function? Now, remember, okay, I'm sorry, this is a typo, guys. Let's remove this one first. Yeah. Now, the function fx equals natural log of x is increasing. Remember the function natural log, it's increasing on its entire domain. And it is 1 to 1. If a function is increasing, remember, it has an inverse. And the inverse of a natural log function is an exponential function, which we denote by e to the power x. So there's a relationship between the inverse functions and its, between the natural log and the exponential function. So let's define it. The inverse of the natural logarithmic function is the natural exponential function. And this is an important property. If y is an exponential function, e to the power x, if and only if x equals natural log of y. So let's look at the properties of the natural exponential function. The domain is from, remember, this is how a graph of an exponential function looks like, e to the power x. The domain is the whole real line. The range is from 0 to infinity. It's never ever going to touch the x-axis. This function is continuous, increasing, and 1 to 1 on the entire domain. It's concave upwards. And if we take the limit as x tends to minus infinity, in other words, when x becomes very, very, very small, the limit is it's touching, but it's approaching 0. And notice if the limit as x tends to infinity, the exponential function really, really explodes. And that's why it's infinity. So the thing we're going to be learning in this section is how do we find the derivatives of these exponential functions? And that's the most simplest and the easiest of all of these derivatives we have learned so far. So let's look at them. The derivative of the natural exponential function. So in other words, the differential of e to the power x is e to the power x. There. And if you have u, a differentiable function of x, then the differential of e to the power u is e to the power u times the differential of u. Think of this as a chain rule, where exponential first is the outside function and the inside function is the u. You can think of that. So let's look at this example. Exponential of 50e to the power 15x. So clearly, it's if you look at the exponential, the x has a coefficient different than 1. So first of all, you're just going to say e to the power 15x times the differential of 15x. And so your final answer is 15 times e to the power 15x. Let's look at the differential of e to the power negative x squared. So the first thing is you look at the power of your exponential. It's not x. It's a little different. So that means in your mind you can think, hey, this is simply chain rule we're doing. So you take the differential of the exponential, which is exactly the function itself, and then times the differential of the power you have. So what is it? It's e to the power negative x squared times negative 2x. Let's write it nicely. Negative 2x e to the power negative x squared. Okay, let's look at the next expression. You have a x cubed times an exponential function. So here, think of the one of all the differential rules. The first rule which is going to be applied is going to be the product rule. And then you apply inside when you go do the product rule, and then you go inside and do the differentials. So the first thing is, this is going to be first function, second function. You're going to have the differential of the first function, if you remember the product rule, times the second function, e to the power negative 5x, plus the first function as it is, differential of e to the power negative 5x. So what do we get? 3x squared e to the power negative 5x plus x cubed. Now, it's an exponential function, so it will be e to the power negative 5x times differential of negative 5x. So your final answer, 3x squared e to the power negative 5x, and the differential of negative 5x is what? Negative 5. I can get this in the front, negative 5 x cubed e to the power negative 5x. Okay. Now let's look at a little difficult problems. Now this one, y exponential to such a huge fourth degree polynomial. Pretty simple. When you take the differential, you will write y prime equals, you simply write exponential as it is, and then you just go ahead and differentiate the power, which is e to the power x to the 4 minus 6x squared plus 7 times 4x cubed minus 12x. And that's your answer. Let's look at the next expression. Y equals 3 plus e to the power 2x the whole to the power 5. So here, the function inside is raised to power something. So the first thing is we have to apply the differential to the outside function, that means to the power, which is 5, and then you do the differential of the inside function. Okay, so let's do that. Y prime is, we'll be doing chain rule, guys, remember that. 5 times 3 plus e to the power 2x to the power 4 times differential of 3 plus e to the power 2x, which is going to be y prime equals 5 times 3 plus e to the power 2x, the whole expression to the 4th, and differential of 3 plus e to the power 2x, differential of 3 is a 0, and exponential to the power 2x is e to the power 2x times the differential of 2x, 2. Let's write it nicely. So you can, this is basically 2 times e to the power 2x, so 5 with the 2 is a 10, e to the 2x comes in the front, then you have 3 plus e to the power 2x to the power 4. Okay, now we are going to look at the last problem here in this slide. It's y equals natural log of then this huge expression. Now remember, whenever we have problems like this, we try to simplify it using the log properties. So the first thing we're going to do is, we're going to write this as natural log of 1 plus e to the power x minus natural log of 1 minus e to the power x. Okay, now we will do the differential. Y prime, now natural log, that means whatever is next to it, you put it in the denominator, guys, and then you take the differential of what was next to the natural logs, minus the same thing for the second expression, 1 minus e to the power x, and then multiplied by the differential of 1 minus e to the power x. So what do you get? You get differential of 1 plus e to the power x, simply e to the power x over 1 plus e to the power x minus differential of 1 minus e to the power x is simply minus of e to the power x over 1 minus e to the power x Make life much more nicer looking here. E to the power x over 1 plus e to the power x plus minus with the minus e to the power x over 1 minus e to the power x. Okay, guys. Now let's look at this problem. You have a rational expression, but the exponentials are in the denominator. Either you can apply the quotient rule, or you can go ahead and change this to a product. Take the denominator to the numerator, and then you can have this as a chain rule. I would prefer doing that. So I can write this expression as negative 7, and the whole expression in the denominator taking to the top, and raise it to the power minus 1. So it's 4 times e to the power x minus e to the power x negative 1. Now, if you take the differential, much more better than the quotient rule. Okay, so y prime is what? Negative 7, and the negative 1 comes out. Inside is 4 to the power e to the power x minus e to the power x minus 1 minus 2 times the differential of the inside function, which is 4e to the power x minus e to the power minus x. Okay, so what we get? 7 times 4 e to the power x minus e to the power minus x squared. Now differential of this function is going to be 4e to the power x minus of e to the power minus x. E to the power minus x times the differential of minus x. So what are we getting? 7 times 4 e to the power x minus e to the power minus x to the power minus 2. Okay, let me get some space here. Times 4 e to the power x plus x times e to the power minus x. Okay, guys. So we have done that. Now remember, there are many ways of doing it. I prefer to use the chain rule. If you want to use the quotient rule, please go ahead and use it. Let's look at this one. Exponential to the power 2 times x times a cosine function. Okay, so here's a product of two functions. So the first thing we're going to do is do the product rule. 1 and 2. So y prime is e to the power 2x, the whole differential, times cosine 0.2 x to the power 5 plus e to the power 2x times the differential of cosine 0.2 x to the 5, the whole differential. Now, exponential to the power 2x is what? E to the power 2x times the differential of 2x, which is going to be 2, times cosine 0.2 x to the power 5 plus. Now e to the power 2x, now the differential of cosine, remember it's a chain rule, and the inside function is 0.2 x5. The outside function is cosine. This will be negative sine 0.2 x to the power 5 times the differential of 0.2 x to the power 5. So what do we get? Okay, so it's going to be equal to, so this one is 2 times e to the power 2x cosine 0.2 x to the power 5. Now this minus comes out outside, minus e to the power 2x times sine 0.2 x to the power 5 times 5 times 0.2, which is a 1, x to the power 4. So final answer 2 e to the power 2x cosine 0.2 x to the power 5. 0.5 times 0.2 is a 1, so it's minus e to the power 2x times sine 0.2 x to the 5 times x to the power 4. Okay, guys. Now, we would like to find an equation of the tangent line to the graph of this function. Remember, what's the equation of a tangent line? It's y minus y1 equals m times x minus x1. Now remember, your m is what? Y prime evaluated at x1, y1. What's my x1? Is 3. y1 is 1. So the main thing is you have to find y prime and then we have to evaluate it at the point x1, y1. So what's y prime? E to the power 3x minus x squared times differential of 3x minus x squared. What do we get? E to the power 3x minus x squared times 3 minus 2x. Now remember, you have to evaluate this function y prime at 3 and 1. Okay. So evaluating this function at 3 and 1, what do we get? E to the power 3 times 3. That's 3 times 3 minus x squared, 3 squared, and 3 minus 2 to the power times 3. Now, 9 minus 9 is 0, so e to the power 0. Anything to the power 0, remember guys, is 1. 3 minus 6, minus 3. So, it's minus 3. Now remember, we just have to write down the equation of the tangent line. So equation of the tangent line is y minus y1, which is 1. The slope is minus 3 times x minus 3, which is minus 3x plus 9, or y equals minus 3x plus 10. Now remember implicit differentiation? So we're going to do it with the help now. We're going to do it with exponentials. Okay. So we would like to use implicit differentiation, guys. Spelling to find y prime. So remember what you do. You take the differential of this whole equation, d dx. So what are you going to see? You're going to have d dx of x times e to the power y minus d dx of 3x plus 10 times d dx of y squared x, and differential of a 0 is a 0. So this is 0. The easy ones, this is negative 3. Now, ddf of x to the times e to the power y. Remember, this is a product first. So this one, you're going to do 1 and 2. So it will be x prime times e to the power y plus x times differential of e to the power y. This is one expression, guys, remember. Plus, and then negative 3, the middle one, and then let's look at the last expression here. It's 10 times, once again, it's a differential of two functions. Let's have one y squared to be y and x to be 2. So what are you going to have? You're going to have the differential of y squared and x in the times the whole x plus the first function as it is, that's y squared, and differential of x. Okay, differential of x is 1. So it's e to the power y plus x times e to the power y. Now remember, e to the power y times dy by dx. And that's it, negative 3 plus 10. Now differential of y squared. Now remember, x and y are not the same. So you do the normal differential, that's 2y, and you multiply by dy by dx. Differential of x with respect to x is 1 plus y squared equals 0. Now remember, gather all the dx's together and put everything else on the right hand side. So we're going to have x e to the power y dy by dx plus this expression, the 20y dy by dx, and rest everything goes on the right hand side. So negative e to the power y, then minus 3 becomes positive 3, and this expression 10y squared becomes negative 10y squared. Okay, now gather the dy by dx's together. Okay, let's try this one. Hold on. So I'm going to write it here on the top, and then I'll open up this slide. So we have x e to the power y times y prime, that's dy by dx, plus 20y times y prime equals minus e to the power y plus 3 minus 10y squared. Now, y prime is or the same dy by dx is x e to the power y plus 20y equals minus e to the power y plus 3 minus 10y squared. Remember, I'm writing y prime just to shorten it. Okay, I didn't want to write dy by dx, that was it. Now, remember we're solving for y prime. So y prime equals minus e to the power y plus 3 minus 10y squared over x e to the power y plus 20y. Okay, so we have used implicit differentiation. Now let's go ahead and solve the differential equation. Now here it says, show that y equals 4 times e to the power negative 4x is a solution to the differential equation. Remember what's this problem saying? Plug this y. Basically, you have to prove when you plug y and y double prime here in this expression, it should give you a 0. Okay, so y is there, but we need y prime and y double prime. So what's y prime? Y prime is what? 4 e to the power negative 4x times negative 4x prime, which is basically 4 e to the power minus 4x times negative 4, which is negative 16 e to the power negative 4x. Remember, we're looking for y double prime. So y double prime is what? Negative 16 e to the power negative 4x, because remember, times the differential of negative 4x. So you get negative 16 e to the power negative 4x times negative 4, or 64 e to the power negative 4x. Now let's plug these values here. We get 64e negative 4x minus y, which is minus of minus 16 e to the power negative 4x. Then there's a 4 in the front. I forgot 4. Hold on guys. Minus y. Okay, minus y means 4 e to the power negative 4x. Oh, sorry, this should be 16y. I think there's a typo, otherwise this will not be right. So this is y double prime minus 16y, sorry guys. So times 16. So this is 64 e to the power negative 4x minus 64 e to the power negative 4x, 0 equals 0. Yeah, that was a typo. This guys should be y double prime minus 16y equals 0. My fault. Okay. So now, as we normally do, once we have done these problems, you guys are going to do these practice problems. So slide number 11 and slide number 12 are the ones you guys need to work on. Thank you.